So today we're going to cover chapter 6, section 1, and we're going to learn about angles and their measures. So what we're going to be doing in chapter 6, and this is chapter 6 from our textbook, we're going to do exactly the same thing that we just did from chapter 5 Brown book. But now, instead of measuring our angles in degrees, we are going to be measuring them in radians. So we're going to define what a radian is. And one radian measure of a central angle theta that intercepts an arc S equal in length to the radius r of the circle. So in this case, theta represents the angle, and it's going to be the arc length divided by the radius, or in other words, arc length, that formula is theta times radius. Drawing our angles, we're going to draw them the same way with an initial side and a terminal side. And in this case, here's our formula to find the measure of an arc length. And whenever we're going to use this formula, theta must be measured in radians. So if they give it to you in degrees, you're going to have to convert it first.
Would this also be calculated?
Let me just show you approximately where one radian is located. So 1 radian is approximately equal to 57 degrees. So 1 radian is going to be here in quadrant 1. So if I ask you to graph 1 radian, this would be the graph of it. So this is 1 radian, which is approximately equal to 57 degrees. Now, on our axis here, remember, this was 0 and 360 degrees. Over here, it's going to be 0 radians and 2 pi radians. Up at the top, where it was 90 degrees, this 90 degrees in radians is pi over 2. Over here was 180 degrees, and 180 degrees is equivalent to pi. Down here at the bottom, 270 degrees, and that's equivalent to 3 pi over 2. So 2 radians is approximately located over here. It's about 114 degrees. So 2 radians is located in quadrant 2, and it's approximately equal to 114. 3 radians is just before the 180. So 3 radians is going to be located about here. 4 radians is going to be located in quadrant 3. So 4 radians will be about here. 5 radians over here. And 6 radians is just before the 360 or the 2 pi, because if you think about it, back to your geometry days, pi was equivalent to approximately 3.14. We just celebrated Pi Day. So 2 pi, if you take 3.14 times it by 2, you get 6.28. So right here, this is 2 pi, so 6 radians is just before that 2 pi. This is 5 here.
Yeah, I saw it. Yeah, I was about to say.
This is 5, and 6 is over here. When you want to find coterminal angles, in chapter 5, remember we added and subtracted 360. Now, when we're working in radians, to find a coterminal angle, we're going to be adding and subtracting 2 pi. Because again, 1 revolution around the circle, when it has a length of radius r, is going to correspond to the angle 2 pi. So let's go ahead, because again, if you think about it, theta is equal to arc length divided by radius. And the arc length, when it's a full circle, remember your formula for circumference was 2 pi r. And if I divide that by the radius, the formula, notice what's left is 2 pi, which is 1 full turn around the circle. So a full 360 degrees or 2 pi. So let's go ahead and find a negative and a positive coterminal angle. So it wants us to find a coterminal angle, and I want to find a negative and a positive, to 17 pi over 6. So what we're going to do is we're going to take 17 pi over 6 and we're going to subtract 2 pi. I need to find a common denominator. My common denominator is going to be 6. So whatever you do to the denominator, do to the numerator. So my new fraction here is going to be 12 pi over 6. I'm subtracting that from the 17 pi over 6. And I get 5 pi over 6. Now, this is still a positive coterminal angle. So if I wanted to get to a negative coterminal angle, I would have to subtract 2 pi one more time. So remember, we already found the common denominator, so we would just take our 5 pi over 6, subtract another 2 pi, which is equivalent to 12 pi over 6, and now I have my negative coterminal angle, and it's negative 7 pi over 6. Now, back in your geometry days, you probably learned how to convert degrees to radians or radians to degrees, and we're going to learn that coming up on the slide. But just know that to convert a radian to a degree, you take the radian measure and you would multiply it by 180 over pi. So the pi's cancel. I could also simplify the 6 and the 180, becomes a 1 and a 30. And then you're just multiplying 17 times 30. So this original angle in degrees is 510 degrees. So if you think about it, if you did 510 minus 360, this gives you 150. So this is equivalent to 150 degrees. And then if you took the 150, subtract 360 one more time, this gives you a negative 210. So if you're uncertain about finding positive and negative coterminal angles at the beginning, you could always convert the radian first and then double check your answers that you're getting to see if you've done the calculation correctly. Let's try one more example, finding a positive and a negative coterminal angle. They're giving us, this time, negative 4 pi over 3. So in order to find my negative coterminal angle, I can subtract 2 pi. I need to find a common denominator. It's going to be 3. Negative 4 pi over 3. This becomes 6 pi over 3. So then now I'll subtract, and this turns into negative 10 pi over 3. To find the positive coterminal angle, I would add 2 pi. And again, I already found the common denominator. So let's just add 6 pi over 3. And I end up with 2 pi over 3. So this is your negative coterminal angle. This is your positive coterminal angle. My original angle, this was equivalent to negative 240 degrees. So if you did negative 240 minus 360, then your negative coterminal angle in degrees would have been negative 600. Here, when you added it, the negative 240 plus 360, this would have given me a positive 120. So again, you're going to become familiar with a lot of these angle measures that are going to be on our unit circle. Now we're going to learn officially the formulas to convert from degrees to radians and radians to degrees. So when we want to convert from degrees to radians, we're going to go ahead and we're going to be multiplying. And I want to multiply an angle measure that's in degrees into radians. I'm going to multiply it by pi over 180. If I want to go from radians to degrees, I flip it. And I'm going to multiply it by 180 over pi. So let's go ahead, because 1 degree is equivalent to pi over 180. 1 radian is equivalent to 180 over pi. And this is how they get the formulas. So let's try some examples. So it wants us to convert 135 degrees into radians. And again, you'll be doing this without a calculator. So we're going to take 135. We're going to multiply it by pi over 180. I could put a 1 under here. I'm going to try to simplify this fraction. So I can simplify and divide both of these by 45. This becomes a 3. This becomes a 4. So 135 degrees in radians is 3 pi over 4. And these are radians. Now, whenever you see numbers, they're not gonna, if it doesn't have a degree symbol, then you know that they're referring to the angle measure in radians. They're not gonna write the word radian after each one of the numbers. So if it doesn't have a degree symbol, then you know the number is radians. Then for the next one, 540, again, I'm gonna multiply it by pi over 180. I can simplify this. 540 and 180 can both be divided by 180, and then this becomes a 3. So then you're left with just 3 pi radians. And then the next one, 45 degrees. Again, we're still multiplying it by the same conversion, pi over 180. And it can also simplify. This becomes a 1, and 45 goes into 180 4 times. So then you're left with pi over 4. And again, these are radians. And if you think about it, pi divided by 4, this is about, if you think about pi as being 3.14, this is about 0.75 or 0.78. And if you think about it, and your axis here, remember 1 radian is about 57 degrees. So 45 degrees would be a little bit less, and this would be about 0.78, which is the equivalent to pi over 4.
Wait, so we're gonna have to know the...
All right, let's try 90 degrees. I already showed you this on that axis on the, again, the conversion from degrees to radians is pi over 180. Notice the 90 and the 180 will simplify. This becomes a 1, this becomes a 2. So pi over 2 is equivalent to 90 degrees. And then now we're going to go the other way. Now they're giving it to us in radians, and we need to convert it to degrees. So now we flip the conversion factor, the 180, and put it over pi. I'm going to simplify my pi's. And then now I can also simplify the 6 and the 180. 6 divided by 6 is 1. 180 divided by 6 is 30. And now you're just going to multiply what remains. 5 times 30, and this is 150 degrees.
Wait, 30 times 6?
We're going to multiply it by 180 over pi. The pi's cancel. I can also simplify the 4 and the 180. I can simplify the 4 will go into 180 45 times, and 4 into 4 once. So now you're just going to multiply 3 times 45, and that's 135. Then the next one. Now, if they give you a negative degree to begin with or a negative radian measure, just know the equivalent will also be negative. So here, notice right above, we already converted the 90 degrees. And we got pi over 2, so this is just negative pi over 2. So my answer, once I convert, is going to be a negative 90. But the 180, and then this simplifies, the pi's cancel, 190, and then the negative stays there. So negative 90 degrees. Now, the last 2 examples here, notice there's no degree symbol. So it's referring to this as 5 radians. So I'm going to do 5 times 180 over pi. Now, if the instructions tell you to leave your answer exact, all you're going to do is multiply that numerator and leave pi in the denominator. If it asks you to estimate it or round to say 2 decimal places, then we would get out our calculator and divide 900 by pi, and this is approximately equal to 286.48 degrees. And then next, if I come over here to 2, multiply it by 180 over pi, and then I get 360 over pi, And then if it asks me to approximate it by dividing 114.59. Now again, if you think about it, when I had shown you where 2 pi or 2 radians were located, remember I showed you that 1 radian was here, 2 radians are here, and again, 114 degrees is approximately 2 radians. So it makes sense. So the formula to calculate an arc length is theta times the radius. Theta must be in radians. So when we talk about an arc length, think about a piece of pizza. Arc length is the length of the crust of your pizza. Area of the sector would be like the whole piece of pizza. So arc length is indicated by a lowercase letter s. So when you see an s, they're referring to arc length. So it's theta times radius. And then area of the sector is 1/2 radius squared times theta. So this would be for the area of the sector or the piece of pizza. So let's do 2 examples using both of these formulas. Okay, so the first example, they're giving us the radius length, it's 18.2. They want us to find the arc length, and remember the formula for arc length is going to be theta times the radius. So the arc length is going to be 3 pi over 8 times the radius, 18.2. I'm going to go ahead and multiply this, and using my pi button, I would get 21.4 centimeters. Then for the area, 1/2 radius squared times theta. So again, square the radius, 18.2 squared, times theta, 3 pi over 8, and this approximately will be 195.12 centimeters squared. All right, last example. Notice theta is in degrees. You can either choose to convert it first, or you can just convert it within the formula. So an arc length formula, again, remember, is theta times the radius. So we could just do 144 times pi over 180, and then times the radius, and then you get approximately 45.7 centimeters. That's your arc length. The area, 1/2 radius squared theta. So 1/2, 18.2 squared times 144 times pi over 180. And we get approximately 416.25 centimeters squared, and that would be your area.